be on page 7 where it says LT 7.2 and 7.3. 7.2 is I can understand. Radian measure. What's a radian measure? It's the ratio of. It's a ratio of. Radian measure is the theta. Radian measure is equal to arc length. It's the ratio of arc length to radius, right? We just went over that. Your entire blue and white paper that you just worked on, including your Google form you filled out, is on radian measure understanding. Okay? 7.3. That's today. I can convert between radian and degrees. Okay. And today's date again, 4/15/25. All right, so we're gonna go over some names. Parts of an angle on a coordinate plane and how we read the angle. Okay, so you ready? If you have highlighters or markers, it would be helpful. If not, it's okay. I have some markers if you want to get 2 colors. Okay. I don't know what happened to all my black, but I have a feeling people took them. Unfortunately. I recommend light colors so you can highlight rather than like possibly erase, but it's up to you. All right, so an angle on the coordinate plane. Can you listen while you're moving around or no? Okay, I'll wait. All right, you ready now? Okay. An angle on the coordinate plane is in standard form when the vertex is on the origin. So vertex is, I'm going to do it in purple. Right there. That's the vertex, right? Is on the origin. And one ray lies on the positive x-axis. That is going to be my starting side, which is what we call initial side. Okay? The ray on the x-axis is called the initial side. We always start with the positive x-axis side as the side for the angle's measurement. Okay? Then the other ray that ends where the angle goes to is going to be called, the terminal side. Okay? Okay. Once you write that. All right. Take a look at the clock. I'm not asking you to read it, just look at the clock. Which way does the clock move? To the clockwise. It goes to the right. Okay? So if it's going in opposite direction, what is it called? Counterclockwise. So if you're going counterclockwise, right? You're going this way. It results in positive angle measures. Okay? I'm sorry? It's up to you. I'm just matching it for you to see like positive versus negative. So clockwise rotation results in negative angle measures. One full revolution is 360 degrees or 2 pi. To make a whole pie, you make 2 pi. Does that PIE versus PI? No. Cancel. Deleting that part from my video. All right. Because you have your protractors with you, we might as well learn how to use our protractor to draw the angles, right? So let me see if I can find. No, I'll just use my graph paper. Okay. So you already have the x-axis on your paper right there, but I don't because I'm going to show you via camera. There we go. Camera. Here we go. Okay. Using your protractors. Okay. You already have the coordinate plane. You do not have to draw the coordinate plane like I do. Okay. So this is my x-axis, y-axis, and the origin. Are you with me? I need you to graph 45 degrees. Draw 45 degrees. So this is what you do. First, we take our protractor in the correct direction. Line it up so my x-axis lines up, right? And my oopsie. Okay, can you see it? No. Okay. I'm recording it. Okay. X-axis, y-axis need to be lined up. So my 90 degrees is on y, and then x-axis has my bottom line of my protractor. Okay. Once it's lined up, we're going to find 75 degrees. Is that before or after 90? Before. See, I have to spell that out sometimes. So we're going to read from the inside. Okay. 0, 10, 20, 30, 40, 50, 60, 70, and then stop at 70, side your sides up, and go halfway between 110 and 100. So which would be right here. Just put a dot or a line, a tick mark, where it's supposed to be, okay? You're not going to draw all the way to that tick line. You're going to use it as a guide to line with the origin, right? Sometimes I like to just put my marker or pen there and then lean against the 0 so I can see that it's going to draw on the correct line. You don't have to connect it all the way down. I connected it because it's at the edge of it, but you can certainly break it, and then you go 75 degrees from initial to the terminal side. Does that make sense? Yes? Okay. I'll use a different color for a different part of the graph. What's the second one? Negative 160. Negative 160 degrees. Okay. So if this is my initial, which way am I going? Clockwise or counterclockwise? We're going clockwise for the negative angle, right? So where should I land? Should I be in quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Oops. Which quadrant am I going to land on? Well, let's see. You don't have to answer it if you're not sure. We'll figure it out anyways. Okay? So we put our protractor upside down. I swear, I'm here, but I'm not here. Okay, so we're gonna start with 0 on the outside now. We're gonna go up to 90 and continue going 100, 10, 120, 130, 140, 150, 160, and then make my mark there. Okay? Take it off. Get your straight edge, or whatever you'd like to use. The edge of your protractor is fine too. Line it up with your origin and the tick mark. You do not have to go all the way. And which part of the angle do we highlight for our negative 160 degrees? Starting with the initial side, we're going to go to the terminal side where it's in quadrant 3. and this is negative 160. This is your second graph. I'm just doing it on the same coordinate plane because it's just easier for me to just do it on one. Okay, but for you, you should be doing it on this, right? The second one, does that make sense? Okay. So this one would be like 75 up here, right? 75 degrees. And then this one should be like here, where you have negative 160 degrees. Do you understand what I'm saying now? On separate ones. Okay. Sorry. That's my bad. I was being lazy. I didn't want to start a new paper and make a new grid. My bad. Okay. So let's try again. Here we go. So the third one is, what's the third one? What is it? 430. Okay, so is that more or less than 360? More. So how much more? A lot more. Let's be exact. 360. It passes 360. It's going to go all the way around and then some more. So if you subtract this, what do you get? 70. Yay! So we're going to go to 70 degrees from the initial. It's going to go all the way around and then go a little more. 70 degrees. So it should be closer to the x-axis than y-axis in comparison to this 75 degrees. So it would be something like that, right? Ooh, Miss Bian just kind of sketched it. Let's see if she got it right. I hope I did. Nope, that's 65. My bad. So 70 would be here. Okay. I don't need to go all the way out there. This is the correct one, not that one. Oopsie daisy. So this arrow is going to go all the way to this one and say this is 430 degrees. And then I'll go back to your notes.
Wait, do we like do a snail?
Yes, you do a snail. You do a snail to measure that angle, okay? So it's in positive 430, so you're going to go all the way around, and then we're going to continue going until you hit 70 degrees, which is about here. I don't have a protractor on my notability. That's why I'm kind of sketching it. And that would be 430 degrees. If it was a negative 430 degrees, where would I land? Where would my terminal angle side be? Quadrant 1, 2, 3, or 4? Think about it. I'm going to do it in, here, I'll do it in blue. It would be going downward, right? Oops, I held it too long. It would go down all the way around and then 70 degrees more. What quadrant are you in? 4, that's why. Do you see why the positive and negatives do matter? Okay, yeah, Casey?
Regardless of the degree or the angle, do you always start from the initial side on the...
Always. Initial side is always the positive side of x-axis. Okay? Initial side is always the positive side of x-axis. That's your standard starting side. Okay? Initial side is always the same. We doing good? Okay, here we go. Radian is a unit of angle measure based on an arc length. 1 radian is defined as a measure of the angle formed when the radius is equivalent to the length of the intercepted arc. We just did that activity. 1 radian is defined as a measure of the angle formed when the radius is equivalent to the length of the intercepted arc. So for example, if this is defined as 1 radian, that means this length and this length is the same. Right? Does that make sense? If I said this theta is 2 radians, right? Then it would be r, and then this would be 2r. Double that. Does that make sense? Okay. Are we okay? So 360 means I have, 2 pi as my radians. And if I have 180, 1 pi. Always, always, always. Always, always, always. Are you writing this down? if we want to convert from degrees to radians, you want to knock out the degrees units, right? So you will put the degrees unit in the denominator. So you can knock out the degrees and then keep the radian. Does that make sense? If you have a pi in your answer, in your value, that's in radians. When you see a pi in your answer or in your angles, that means that angle's in radians. Okay? Are we okay so far? So if I do 30 degrees, okay, put 30 degrees over 1, multiply it. What should go in the denominator? 180 or the pi? In the denominator, I need to knock out the same units. I need degree over degree. So what do I put here? Degree is what you would put in the denominator. Does that make sense now?
Yeah.
180 degrees. So it's not the same as your activity in this case because you're going from angle measure in degrees to radian angle measure. Okay? So this would be pi for 180. So this would be 30 goes into 180 how many times? 6 times, 1 time. So 1 times pi is pi over 6. You cannot write it in decimal. You have to write it in fraction with the pi. So this part, is going to be difficult for some, but not impossible. You just have to go slow, okay? Figure out a factor that goes into both numerator and denominator. Try to simplify it as much as you can, okay? All right, so 150. How do we go from 150 degrees to radians? What should go in the denominator? 180 degrees. And then what goes in the numerator? Pi. So what goes into both 150 and 180? 30, 10. Either one works, okay? So if 30 goes into 150, how many times? That's the part you want to use your calculator for if you cannot figure it out in your head, okay? So if I did that, it would be, I would just put it in my calculator. 150 divide by 30 and you get 5. 180 divide by 30 and you get 6. So those are my two numbers that I need. 30 goes into 150 5 times. 30 goes into 180 6 times. Do you see how it's working? Then you multiply. 5 times pi is 5 pi. 1 times 6 is 6. And there you go. You have your radian. 5 pi over 6. Okay? If 1/6 of a pi, or pi over 6, is equal to 30 degrees, 5 times more will be 150. Right? Are we doing okay? Okie dokie. All right. Negative isn't that much different. You just use the negative 220 degrees over 1. Make sure you keep the negative around. What should go in the denominator? 180 degrees. And then what goes in the numerator? Pi. And we get, we got to figure out what goes into both. I'm dropping the zeros to see 22 and 18. What will go into both 22 and 18? Really? We're going to guess on that? 220. Here you go. 220 divided by 20 gets me 11. 180 divided by the same number, 20, gets me 9. So it is going to be negative 11. This is negative 11 over 9. So it's negative 11 pi over 9. See how pi's are all in our answers for this one?
Yeah.
If you see pi, it's in radians. Okay? If you have like sine of pi over 6, you have to put your calculator in radian mode. Okay? If you have an angle that's written out in radian, your calculator must be in radian mode. Okay? I'm just giving you the heads up for now. We'll go over that tomorrow or Wednesday or Thursday for you guys. Okay? Ready? These are already in fractions. You don't have to put over 1. It's already in fractions. Leave it as over whatever denominator it has already. Okay? So 4 pi over 3. You're going to multiply that by... How do I get rid of that pi? Pi needs to be in the denominator. And what goes in the numerator? 180. Okay? Then we have pi over pi is 1. Can 3 go into 180? Yep. How many times? 60 times. What's 60 times 4? 240 degrees. Not bad, right? Yeah? If you want to keep everything in degree mode, you can always convert all the radians to degrees before you even put it into your calculator, and you don't have to change your mode. Okay? So this is a negative 5 pi over 36. I'm going to make sure that this numerator has that negative. As long as one of the two parts in a fraction has a negative, it makes the whole thing negative. Okay? It has to be just one though. So I'm always going to put it on my numerator. So if I were to rewrite it, it would look like this. Negative 5 pi over 36. What would I multiply this with? 180 over pi. But can I also use a different equivalence? 36. I've seen 36 somewhere. Right? So instead of using this, just to make my math simplifying easier, I could use 360 to 2 pi. Right? 360, 36 goes into 36 once. 36 goes into 360, 10 times. Then I have negative 50 over 2 pi. Can I simplify 50 over 2? Oh, sorry. I made a mistake. Pi over pi goes away, right? Yes. So this becomes negative 25 degrees. How you doing? Is your head hurting? A little bit? Okay. All right, we're almost done. What should I multiply this with? You can use 360 over 2 pi. You could use 180 over 2 pi. Can I use pi over 180? Probably not, because do we want pi squared or do we want to get rid of the pi? We want to get rid of the pi. So we want the pi in the denominator. Then we can knock them out. That means 180 goes on the top, right? If you use 360, you still end up with the same answer, as long as you have 2 pi underneath it, okay? So 4 goes into 180, how many times? Calculator, if you need it. I think it's 45, right? So 7 times 45? I only did it 5 times, so kind of memorized it. Okay, what do you think? All right, I'm going to save you from the torture of learning about coterminal.
Thank you.
Okay? The key is the x-axis part, okay? So I'm going to highlight the x-axis so you know what I'm referring to, okay? Even though the angle for this one, let's say it's 120, and it's asking you, let's say it's asking for like sine of 120, okay? You'll learn how to do that. But I just need you to understand, we don't take 120 to figure out opposite over hypotenuse. Does this make a right triangle? The answer is no. 120 does not make a right triangle because the largest angle should be 90 degrees for a right triangle, yes? Okay, so you have to use a reference angle in order for you to figure out where it lands on the terminal side, okay? So what we do is we take this angle from the x-axis to figure out what your reference angle is. For this one, it would be, since it's 120, and how many more to get to 180? 60. So the reference angle would be 60 degrees. Does that make sense? Yes? Okay, so we're going to graph 225. Do you want to use your protractor, or do you want to just eyeball it? Eyeball it. Okay, 180, and then some more, right? Not quite 270, which would be 390s, right? 90, 180, 270, right? It's not at 270, it's before then. How much more? You can't do the math? Do the math like this. 225 minus 180. How much more? 45. Thank you. Okay. All right, we're awake. Okay. So it's 45 degrees. It's like half of this angle between 180 and 270. Okay. We don't make the reference angle to make it to the y-axis. We make the reference angle to make it to the x-axis. Okay. So if we make it to the x-axis, what's this angle right here? From 180 to 225. We just figured it out. What is it? So that's your reference angle. Does that make sense? Okay, your reference angle is 45 degrees. Isn't 45 degrees one of the triangles that we know the side ratios for? That's why. Okay, no matter which angle you choose, you're going to be able to drop a line and create a right triangle. Do you see it? Okay. All right, so negative 310. Which way am I going? Am I going right to left or left to right? Sorry, right to left. I'm going the opposite direction, counterclockwise. I said it was the same direction. Hello. We're going to go from clockwise. So we're going to go from 3 to 9, okay? 3 to 9. So how far do we need to go for 310? Is it before or after 270? So, okay, so this is 90. This is 180. This is 270. How much more than 270? Yeah? So 40 degrees, maybe probably slightly lower than 45. So there it is. So what's my reference angle here? 50 to make another 90, right? So your reference angle is 50 degrees. Do you know the difference between a less than sign and an angle sign? What's the difference?
On the equal sign, it kind of looks like a triangle that's missing a side, and it's lower than the less than side, which is our top.
Good. The bottom side should be flat, like x-axis. Okay? If it's up in the air like this, I'm going to think that you mean less than. Reference angle is less than 50 degrees. Okay? So you don't want to make sure you're using the right notation. It's got to be very clear and specific. I'm talking to the people who have sloppy handwriting. You know who you are. Okay? I need you to really make it clear that's an angle, not a less than sign. You know what happens if Ms. Bian misunderstands something on your paper. You're not going to be happy. All right, so 2 pi thirds. All right, so this is 0 pi. Okay, and 180 is a full pi, right? So 2 of these make 360, right? 360 degrees. Yes? Okay. I need to get 2/3. So which means I'm taking a whole pi and breaking into thirds. Okay? So I'm taking 180 and breaking into thirds. How many are each of the angles? Come on. What is it? 60. Yay. 60 degrees. So it's 2 of those. So where am I at? This is 60. Here's another 60. And then here's another 60. That's 1, 2, and 3, right? How much should I move? From here to there, or is it all the way over? This is 60. This is another 60, and this is another 60 degrees. How much should I go? If it's 2 pi thirds. Just to 60? Isn't that pi over 3? That's 1/3. Yeah? Okay, so where's 2 pi over 3? This is 1 pi over 3. This is another pi over 3. There you go. This is where you should land. So I'm going to erase everything else. Okay? So which one's my reference angle? If this is the angle that I was given, 2 pi thirds, then what's my reference angle? I left it up on purpose. 60 degrees, that can be closest to the x-axis this way. Does that make sense? No. Okay. Can you make... You have to be able to get to a reference angle that would reach the x-axis in the shortest angle. Okay? This is 120. Agree? You understood why it was 120? Give me a head nod so I know you're tracking with me. Okay. If this is 120, even though it's asking for 120, the reference angle you would use for your trig would be the 60 degrees because it's closer to the x-axis. Does that make sense? Yes? Because you want to be able to make a right triangle. Can you make a right triangle with 120? Nope. So you use the other side of it. The reference angle is 60 degrees this way. So reference angle is 60 degrees. Okay? Yep. So again, okay, so I take 180, which equals to 1 pi, right? 1 whole pi. So if I have a third of that, that would be 180 divided by 3. 180 divided by 3 is 60. So 60 equals to pi thirds. If I have 2 of these, I'm doubling on this, which is, there you go. Okay? That's what we're going to learn today with unit circles anyways. I just gave you a little sample. Yep.
Could you also just times it by 180 over 5?
180 over 5? Why?
Over
Pi?
Yeah.
Why would you do that?
Because then you can erase both of the pi's, so then it'd be 360 over 3, which is then equal to 120.
360. Okay, tell me again. How did you set it up?
So it's going to be the 2 pi
Yep.
over 3.
Yep.
And then you're going to times it by 180 over 5.
Yep, you could do that.
Okay.
It's the same idea.
Okay.
Because look at this. Pi's cross out.
Yeah.
3's cross out. And this one becomes 60, right? Isn't that doubling the 60?
Yeah.
Yeah, it's the same thing. Okay? Any questions? I was trying to make it make sense with the picture of having 1/3 for 180. That's all. Okay? So yes, you can do it next way, which was the way that I taught you not too long ago on Monday, right? Questions? We're good? Okay, moving on. Here we go. Trig functions. Let theta be an angle in standard form, and P, the point, x, y, be a point in the terminal side of theta. Okay? So if it's a point on the terminal side, this is what it's saying. This is the initial side, right? This is the initial. The terminal side is this one, where the angle ends. So this P is going to be represented just like all of our points on coordinate planes. X first, then the y value. Agreed? Okay, you read the x and then you read the y to find the point. Okay? X, y. The distance from P to the origin is the radius. This is talking about the radius. Are we clear on that? Do you agree that that's the radius of a circle? Yeah, okay. It can be found using the formula. Let's do x squared plus y squared equals r squared. Right? R is the hypotenuse. X and y are my axes, right? Sorry, the legs. And that should take you right where you need to be. Okay? So, if I were to say sine of theta, okay, I'm going to just tell you, this is not going to make much sense, but it will make more sense when you use the unit circle, okay? So just stay with me on this so you can go back and refer to it in your notes when you need to, okay? So sine is, okay, so, ka, to, I put that on there. Do you see it? So, ka, to, trig ratios right on the board, right there, anchor chart. Yes? Okay, so, ka, to, which side is the opposite side to this reference angle, theta? To y, so you put y over. What's the hypotenuse? R, yay! That's it. Okay? Cosine is adjacent over hypotenuse, which makes it, which one's the adjacent leg? X over R. Are you doing okay? Give me a so-so, no good, or yes, I'm tracking exactly what you're saying. Okay. All right. So tangent is, what is it? Opposite over adjacent, which makes it y over x. Okay, so far so good? Cosecant is its inverse of sine. These two guys are the evil twins of each other, okay? So what do you do for the cosecant? Reciprocal of sine, right? So it'd be r over y, okay? Secant is its evil twin of cosine. What? So what do I do with cosines? X over r. Reciprocal r over x, okay? And then tangents, evil twin is cotangent. So what do I write for the ratio? X over y. Okay? All right. 5, -2 is a point on the terminal side of theta in standard form. Find the exact values of the trig functions of theta. There you go. Okay, 5, -2. 5 is to the right, 5. -2 would take me down this way, right? Let me move it just a smidge. Okay. So this is 5, -2. Okay? Does that make sense so far? Do you want me to move it up? Better? Yeah. Matthew, if that chair's in the way, just take it down. No? You're okay? No, I meant Matthew's shade. Next to Kavya, is that chair in the way? All right, cool. All right. 5, -2. So we're going to try to find the side lengths. It's not going to be that hard. Watch this. If I were to drop a line straight down from that 5, what's the distance between the x-axis and -2 here? 2, 5, 1, 2. It's -2, correct? Yes? Okay. What's the distance from the origin to the 5 then? 5. Do we know the hypotenuse yet? That's when you use the Pythagorean theorem. Okay, so it's -2 squared plus 5 squared equals r squared, right? So -2 squared is 4, 5 squared is 25, so r squared is equal to 29. So what's r alone. Yep, square root of 29. Okay, so you have square root of 29 for the radius. You have 5, -2 for the legs, respectively, where this part right here makes the right angle. Are we doing okay? So the theta part is this angle right here. That is the reference angle. Because the reference angle is closest to the x-axis already, you don't need to look for this one. Does that make sense? Okay. So what is sine of theta? Sine of theta has to be opposite over hypotenuse. So you just put those in. -2 over rad 29. Now, can I leave rad 29 in the denominator? You don't want to. It's just bad form. So we're going to multiply numerator and denominator by rad 29. And you should get -2 rad 29 over 29. Anything else I can simplify?
How can a length be negative?
A length, because it's trig, not the distance we're talking about here. In this case, because they give you these values, you have to use the same values. So you know exactly which direction you're at. Does that make sense? Because if you're here, up here, then that would be +2, right? +2 and +5. You would know exactly where the terminal angle is. Does that make sense? That's a great question. Thank you. Okay, are we good? The only thing that's considered distance is the radius. Okay. All right, cosine theta. So what's the ratio that I should be looking for? Opposite over adjacent, opposite over adjacent, opposite over hypotenuse, or adjacent over hypotenuse. There you go, A over H, right? So A is 5. What's the hypotenuse? Rad 29, square root of 29. So what do? Both sides? Which both sides? Thank you. So multiply numerator and denominator by rad 29, square root of 29. Then we get 5 square root of 29. And what's on the bottom? 29. You got it. How is it? What are you doing, Evan and Nathaniel? Are you being bored? Is that why? Tangent? Nathaniel? Since you're bored. -2 over 5. Do I need to simplify anything? Good. Okay, cotangent. Evan. 5 over -2. Okay, secant. Can I call on anyone? Ishan. Secant. For this one, I wouldn't use this. I would use this to get the reciprocal. You know why? Exactly. You don't have to rationalize it if it's in the numerator, right? So why not go back to where we had it in the denominator? Okay. Cosecant. Evil twin to sine. Megan? You got it. Pretty easy now, huh? Yes? Is it making sense? All right. Okay. Do you want to work on this first? As kind of like a break from Mrs. Mian? Or do you want to go